Good evening, everyone. We will start in a minute or so. Good evening, attendees. Can I just get an indication if you guys can hear me? Just a show of hands, please. Thank you, Joshua. Thank you. All right. Welcome, everyone. My name is Busisiwe Matehu, and I'm going to be your host for today. Welcome again to the webinar for the Engineering College of Science and Technologies. Thank you again for taking the time to join us in today's webinar. We are very excited to be speaking to prospective students. Welcome again. So just before we start, I'm going to just be taking you through a few housekeeping rules. So you can see there just the first one. You can just turn off your notifications, and this is just the instructions on how to do so. I'll just keep the slide on just for a few seconds so you can just take note. If you can just please do that, turn your notifications off. As well as with regards to question and answers, there is a function on the top tab. It's a Q&A. That we will not be taking any questions during the presentations. So if you've got any questions, just please jot them down in that chat box and we'll attend to them at the end of the session. And then just please kindly note that the session is being recorded. You will be receiving the recording in a few days post the presentation. Yeah, and as indicated, any questions and answers, just please post them in the chat. And a copy of these slides and recording will also be shared with everyone. All right, just to start off the session again, welcome to the Engineering College of Science and Technology. This is our webinar. It's the student information session. Your future in engineering starts here. So thank you again for joining us. With regards to the agenda, we're going to be looking at the purpose of the session. You're going to be talking about discovering the institution, exploring engineering programs that we offer, as well as the support informed decisions. And your presenters for today, we've got Lisa Rootman. This is the head of college. We've got myself, Busisiwe Mateo. I'm the quality assurance officer. We've got Sonny Mpatu, which is the program advisor. We've got Christabel Piri, lecturer. Friki Marks, also a lecturer. And in our audience, we also have Danny Stoop, who's also a lecturer. So welcome, Danny. All right, I'm going to be handing over to Lisa, who's the head of college, for her introductions. Thanks, everyone.
Thank you, Busi. Hi, everybody, and a warm welcome to the Engineering College of Science and Technology's virtual information session. We're very happy that you decided to join us this afternoon, early evening, and to start your dinner a bit later today so that you can get a bit more information about our institution and our programs. I'm sure we have some parents on the call, some matriculants, or even earlier learners in earlier grades, as well as perhaps graduates, working individuals. So just a warm welcome to all of you and thank you for joining us. So The Engineering College of Science and Technology, ECST, was established as an independent South African institution. We are accredited and provisionally registered by the CHE and the Department of Higher Education. We're going to talk a bit more on these things later on, whether it be myself or one of my colleagues. But we are really focused on delivering cutting edge engineering education. We want to be able to deliver graduates that can become gainfully employed, but also make a difference in the engineering industry, whether it be in South Africa or abroad. So our programs is focused on engineering only. So that is one of the things that makes ECST stand out as a private higher education institution. And I'm going to touch on various different things through the next few slides. So as we said, we're newly accredited. We registered with the, or provisionally registered with the Department of Higher Education and Training. We accredited. A very important point is that we are endorsed by the Engineering Council of South Africa, and we'll get to that a bit later as well as to how it holds value in the employment market, and that we are registered on the National Qualifications Framework, so we registered with SAQA, and we are committed to developing technically skilled and ethical graduates. Okay, so we, at the moment, for the February 2026 intake, we're going to do the Bachelor of Engineering Technology in Electrical Engineering. So that starts on the 24th of Feb 2026. It's pitched at NQF level 7. It's got 425 credits. What makes it stand out is the fact that it's a 3-year degree and not a 4-year degree. Also, it's our mode of delivery. So first year is face-to-face. Second year is a split between online and face-to-face. And our third year is online with workshops and a few assessments on campus. The reason we've done this is so that our students can start integrating into the workplace in their third year, which really holds a great advantage. So we have an industry-aligned curriculum. Our curriculum is developed by industry specialists. It's very practically based. We've got remote labs. Our software, etc., is really focused on practical ability, and we're going to talk a little bit more on this. We have strong student support systems, and we're going to get to that a little bit later as well in terms of what student support we offer. But one of the things we're extremely proud of is that we are really focused on the supporting the students throughout the entire journey. So from when they enroll until when they graduate. And we actually have a learning support officer for each program that is with the student from when they enroll up until when they graduate. We have experienced academic and support staff that supports our students, guides our students, and lectures our students throughout their journey. What's also great is that our qualification is accredited and registered in South Africa, but also we are recognized globally. And there's pathways to further studies abroad and also in terms of employment.
All right. Thank you very much, Lisa.
Thank you, Pussy.
Thank you. The next presenter will be Sonia, so program advisor.
Okay, hi everyone. Can you hear me? Okay, hello everyone. My name is Sonia Mpato, your program advisor. So today I'm going to cover the admission requirements for our qualification. So number one, we need a matric certificate, national certificate or equivalent NQF level 4. And then we need a minimum of 50% in English. We need 60% in mathematics or technical mathematics. We need 50% in physical science or technical science. And lastly, we need basic computer literacy. And our alternative entry, the applicants with previous work experience, relevant learning knowledge could enter the program through a recognition of prior learning, which is RPL process. The applicants who will be turning 23 or above in their first year of study could be submitted subject to obtaining an exemption certificate from the matriculation board. And applicants aged 45 years and above can be submitted subject to obtaining mature age exemption from the matriculation board. And then the application process for our qualification is the applicant must apply online. Our application fee is 500 Rand, and you need to upload the supporting documents such as ID, matric results, or relevant qualifications, grade 11 marks for provisional admission. And we also need SAQA evaluation for international or foreign qualification. If your application is successful, we're going to provide the student with an acceptance letter, enrollment contract, and a payment plan. So our tuition fee for this qualification is 250,000 for 3 years. So year one is 90,000 Rand, year two is 85,000 Rand, and then year three is 75,000 Rand. And then we have two payment options. So number one, if you want to pay with full settlement, you will get a 5% discount. And then if you want to pay with monthly installments for 11 months, you have to pay an upfront of 30% deposit. And lastly, we have a special for our early birds from now until the 15th of December. Thank you so much. I will hand over to Lisa.
Thank you so much, Sonia. Just to add on to the early bird discount, it is a 10% discount that's running from now until the 15th of December. So that's off the total fee from the first year. So that's off the 90,000 Rand that Sonia was referring to. In terms of student support and development, so we provide our students with academic tutoring and mentoring. So outside of the lecture room, there's also tutoring taking place, career and employability workshops. We well connected within industry, and throughout the duration of our student studies, there will be workshops to prepare them for the workplace. The all-round wellness of the students is very important to us, so we also support that throughout the duration of the studies, and we create and foster an inclusive and supportive learning environment. Our facilities, here's just a few pictures of our facilities. You can see our labs, our workshops, our recreational space. And as we said, it's very practically based. So you can actually see our students in the workshops and in the labs learning. And we've got Christabel there in the workshop as well. Okay, I'd like to hand over to Christabel to talk on the curriculum.
Hi, good evening, everyone. Are you able to hear me? Okay, great. Thanks, everyone. I'm going to talk about the units that you are going to find in a Bachelor's of Electrical Engineering. You might be asking yourselves, like, what is this course? You understand? The field of engineering is concerned with the study and application of electrical and electromagnetism. So what is this? It's the production of electricity. You talk about how it is produced, how it is distributed, and how it is laid, around the houses and industries. So for you to qualify for this and to get recognition out there in the industry, you might have to pass all the modules or the units that we offer, starting with the first year, as you can see on the first slide. The curriculum outline and delivery method for year 1. We have engineering mathematics 1, which is equivalent to high school mathematics, which is level 1, and NQF is level 5. It carries 15 credits. And what it means by 15 credits, it's 150 national hours. You know, you need to be exposed to this mathematics, which is used in the industry out there, but it's an introduction to mathematics. And like my colleagues have already pointed out, that you need to have a matriculant that have passed mathematics or physical mathematics. Not, if we don't do math literacy, you need to have passed mathematics, which is physical maths. And there's another subject which we call electrical circuit theory analysis. It's also level 5 and 15 credits. There's engineering dynamics and mechanics, which is similar to physics, also NQF level 5, also 150 national hours, which is 15 credits. We have engineering design and drawing, 5, which is level 5, 15 credits. And this, the last one in the first year, first semester, we have industrial experience research project. On this one, you guys are going to be exposed to, you know, industry-related projects where you're going to research about the industry requirements and be able to do either a simulation on our softwares that we have on electronic labs and be able to draft a research in a standardized manner, and then we are going to assess that research. You can see there's part A, and we have part B in the second semester. So in our first year, it's going to be full-time, which means that you guys are supposed to be in class face-to-face and to meet with the lecturers on our campus, which is Midrand campus. So once you pass these units in first year, first semester, that is the only time you're allowed to go to semester 2. Remember, you can't go and do mathematics 2 if you have not passed mathematics 1, being that mathematics 1 is taken as a prerequisite for you to do mathematics 2. All right. And for you to pass these units, you need to get minimum of 50% in each subject. You don't get 50%, you don't qualify. And the other important thing I need to point out as a lecturer is you need to understand that in the course of the semester, you're going to be assessed. In each of the units, we have got different assessments, which we call summative and formative assessment. We have assessment 1, assessment 2, assessment 3, and assessment 4, which will be your final examination that you guys are supposed to pass before you go into your second semester. I hope you got that. Then in the second semester of year 1, you are going to do engineering mathematics 2, right? It's a NQF level 6, not level 5. Why? Because it's a high level on the Bloom's taxonomy. It's not level 5, it's level 6. And it requires you to be critical thinkers, meaning that you are now thinking at a level higher than the level that you were thinking on in level 1 of semester 1. And these all modules or units are all 15. You can see 15 credits, except for the industry experience research, which is part B. So we are going also to, test you or assess you on another project, which is on higher level. As you can see, it's a level 6, and it's 10 credits, as also level 1 was 10 credits. You will do engineering programming. Then fundamentals of electronics, now you're starting to deal with electrical and electronics. So these will be like on diodes, resistors, and all those things, calculations, because you guys are going to be designers. So it's not that you are learning on how to do wiring, but you're doing hands-on practicals and also learning the theory part and the designing part of electrical engineering. Okay. Then we are moving on to our second year. You'll find that in the second year, it's going to be blended learning, meaning that we have a combination of face-to-face, which is physical classes that will be running on campus, and also online. So year 2 is blended learning, and for the online, it's not that it's something very different or difficult. It's very simple. How it's simple, is that you're going to be in class and it's going to be real-time communication with your tutors or your lecturers. And all the recordings for the sessions are going to be saved on the page, which we call the module page, and you guys are going to have access to the recordings. And that makes it very simple and easy for you to catch up with, any of the classes that you might have missed. So you can come to class and then some other topics will be taught online, and yeah, you'll still be a par and be able to pass. So in year 2 of semester 1, you're going to do mechanics of machines. And guys, this subject is very interesting because it's now catching up with the technology. We are teaching you on how to design robots. Electrical engineers are found in all the fields. So under mechanics of machines, we train you on how to create any machinery that is movable. It can be a robot, it can be automobile, it can be an aeroplane, it can be anything. So that is on mechanics of machines. And it's NQF level 6, 15 credits. You have to also go through engineering mathematics 3. And take note that you cannot do engineering 3, mathematics 3, if you have not passed engineering mathematics 2. You can see it started with 1, 2, then 3. And mathematics 3 is 7, which is NQF level 7. And it's 15 credits. Then the other unit is transformers and switch gears. Transformers are used everywhere to increase voltage or reduce voltage. So we'll be training you on how transformers operate. It can be a 3-phase or a single-phase transformer, and switch gear systems of big power plants or any electrical engineering industry where they are using such. And this unit is NQF level 6, and it has got 15 credits. Then you learn about rotating electrical machines, and these are electric motors. We can talk of turbines. We can talk any machinery that is using electricity. So you learn about electromagnetism. What makes a motor to rotate? What makes a motor to move an equipment? So those are the things that you're supposed to learn about. And then we have project planning, management, and costing. Yes, as electrical engineers, you don't only know the engineering side, you also have to know the project management side, meaning that you're exposed in the field where there are project managers, there are mechanical engineers, electrical engineers, and so forth. So you need to be able to plan a project and then to execute a project from beginning to the end, and also to keep controlling your project. It can be a power plant installation. Yes, you need to know how a project runs. And that one is only part A because it's first semester of year 2. And we do have another one coming in the second semester. And second semester of year 2, the modules that you're going to do are power generation, transmission, and distribution. I think for most of you that might have done this before, those that are already in industry, power generation, we're talking about how electricity is produced, how a generator works, and different types of generators and all that. And transmission is how power is transmitted from the power plants to the consumers. And then you distribute them into different fields or different domestic places. This is NQF level 6, and it has got 15 credits as well. Then we have another unit, which is electrical safety, earthing, and lighting protection. This is going to talk about earthing and how you protect equipment from lightning, and also just electrical safety measures that you guys are supposed to know before you are exposed to such things. This is NQF level 6, and it has also 15 credits. Then we have power electronics and variable speed drives. You go into details, you understand it's very intuitive units that we've got. And electronics, you know what are electronics, can be diodes, resistors, capacitors, mention them. How do they work? Variable speed drives are those things that can adjust when the speed is changing or current is changing. And then we have another unit which we call power quality and energy efficiency. So this, you're now talking about the power output and its efficiency. It's NQF level 6 and 15 credits. Then we'll look at project planning, management, and costing, which is part B. It's going to be a different project, but also industry-oriented, meaning that we give you a real-time scenario of what is happening in the industry, and then we ask you to research and then do the finding. After you find out, then you deduce the conclusions and then recommendations as an engineer, obviously. Okay. And then in the final year, which is year number 3, third year, it's going to be online. You can see that year 3 is fully online and giving you the freedom to work alongside with your studies, because most of you might be working and others have already maybe found jobs. So we give you time to learn at the pace of your own. You can learn at your own time. Like I mentioned earlier, we record our sessions, and if maybe you were at work, you didn't attend the class, you have time to come and review the recordings. It's going to be accessible by anyone. Okay. So year 3 in the first semester, the units are Power System Protection, NQF Level 7, 15 credits, Electrical Utilization Engineering, NQF 7, 15 credits, Power Generation, Electrical Control Circuits, and PLC Programming. All these are 7 credits. 7 NQF Level 7, 15 credits. I beg your pardon. Then Electrical Control Circuits and PLC, it's also 7, Level 7. Then technology, sustainability, and society. We know we are living in the world of, global warming and all those things. So you guys are going to learn about advancements in technology, especially in the field of electrical engineering, what is happening out there. You're going to learn about different softwares that are being used in the industry. We want to produce you to be ready, industry ready, so that when you go to the industry, you are equipped with what the industry is in need of, and also on sustainability. All right. Then second semester of year 3, which is your final semester, you're going to learn about data communication for power system monitoring, 15 credits, NQF level 7, and final year project, which is electrical engineering. This is a big project, and you guys are going to be exposed to a lot of things, meaning that you're going to integrate all the projects that you've done from year 1 to year 3, and it's going to be something that is robust to equip you to go and join the industry. And you can see the number of credits. For sure, it's 40 credits. And what does it mean, 40 credits? You need to be exposed 400 national hours learning and also discovering what is happening out there. Then you are going to learn about technology sustainability. This is part B. Part A was already mentioned in first semester. Okay. And like I've mentioned, that we are here to take you there, and how we are taking you there is to link you to what the industry is in need of. We always try our best to equip you with the skills and knowledge that are needed by the employers out there. I think this is my last slide. Thank you so very much, Sonia.
Thank you very much, Christabel. It is Freaky next. Thank you. You unmute, Freaky.
Okay, I'll unmute. Thank you. Okay, yeah, so a lot of what you've been told about now, you're going to see in the practical that's been done over the BXX 001, 2, and 3. So, and you see, we start with the measurement and science workshop. Okay, so sorry, there's the first slide. So we're going to look at the virtual labs, but first we're going to look at the real practical that you're going to do, hands-on practical. As you see, we start with the, so you're going to have to be able to build a bit of wiring as well. So connected together, as you can see, we start with the passive components, and then we go over to the active components, and in this experiment we look at the diode and we look at the characteristics of a diode. Okay, so and later on we talked about power electronics. Now we've got diodes for signal, so small current and voltage, versus then the power electronics is where we basically then we can carry high current and high voltage as well. And then, as you can see, we experiment with Planck's constant setup. So we looked at different light emitting diodes that emit the photon energy in different bands, and some of them you can't see them with if you look at the infrared band, so we can only see in the visual band. Once you go over to the infrared band, so one of the techniques that you can use is to use your mobile phone camera, because the camera normally you can design it to a bit overlap into the infrared band, and that's why you can see it with the camera, but you won't see it with the naked eye. So some of these basic electrical experiments is we look at sound, we do some sound measurements, so we display it on the oscilloscope, but we also use the audio meter to measure the levels. So which would happen in factory, because in the factory they would determine levels which is acceptable. That's why you'll see people in factories has got headphones on it, so to protect their ears against that. Then next we go into the electronic side, so electronics and wiring. So now we look at the printed circuit board. We start with a bit of a Vero board so that you can build your own circuit, simple circuits, and then also a printed circuit board where you build the circuit on and you learn some soldering. Now, one of the subjects that you also see is communication. Now, here we do a bit of practical of communication. So we built our own cables, not just not just the LAN cables, but we also look at the optical cables. So how do we connect them, the connectors, the measurements that we do on both of them in terms of communications. Then we'll talk about all the other equipment that we also use in communications. Then getting to the motor side. So here you see a typical example of a small DC generator. So we look at DC motors, DC generators, and AC motors, AC generators. So we've got a practical setup that you can just change and convert that in from an DC to an AC machine. As you can see here, in terms of control circuits, we start with an H bridge. Now, H bridge is because it looks like an H, but it gives us the functionality that we can control the current flowing through it in different directions. We change the voltage, so we can change the direction of rotation of the motor. And we use pulse width modulation. Now, pulse width modulation is not just applicable to the H bridge and to the switch mode power supplies, but also applicable to the variable frequency drive, because the output of that is also a pulse width modulated signal. So, but we do that in detail. We discuss the waveforms, we discuss the electronics inside the variable frequency drive. And then we use Arduino circuits to do some programming. And those Arduino circuits we use to generate the signals to drive the H bridge, so that we can control the direction of that motor. Then we go on to advanced control, where we have a little robot that you need to program to follow a line. And we start with the introduction to PLC programming. You've seen PLC programming also as one of that items. And one of the things that we can do is PLC timers and a traffic light simulation. So we can do that practical in the workshop, but I'll show you later on. We can actually also do that through the remote labs, so that you can write your program, download it, and verify that it's working. Then we get to BX003C, where we look at the electrical and industrial automation engineering workshop. So there's the PLC training kit that you will use, so that you can program. You can see this little kit over here has got different, we talk out mechanics of machines. So here's different processes that you can control now via the PLC. So that's what makes it so. And there's one of the examples, coupled tanks, and you must now program the PLC to control the tanks. So it mustn't overflow, but it must be filled up to a certain level. So that's one of the activities inside the PLC. So there's an example of the AC motor that we control with the variable frequency drive and the PLC coupled to the processors. So there's quite a variety of different tasks that we do in terms of the PLCs, just as the different tasks looking at AC and DC motors. Then we go on to power transmission and distribution. So inside here, there is a three-phase transformer with which we then isolate ourselves from the utility supply, but we can also then use this and we can step up and the voltages up and down as required. Now, if you look at power transmission and distribution, one of the things if you now setting up let's say a new substation and a new transformer, then you want to load the transformer slowly, and sometimes you want to also be able to control the input voltage, slowly step up the voltage. But here's a variety of different tasks that is now focused on power transmission, different aspects of power transmission and distribution that's normally used by the utility that's supply the power. Part of this is also then here we've got a motor driving a generator, so that's typically the prime mover in our case is now AC motor driving a synchronous generator. Now, what happens in the utility, we do it for our simulation, we've got the motor on the input side, but the prime mover is normally some type of turbine, which can be driven by water or by steam to generate the necessary electricity. So this is the example of that. So this is all that you're going to do in the lab itself. But then you've got the remote labs where you've got different software available. Now, up to now, we at this picture where you're basically in the lab and you can directly access the lab equipment. While with the virtual or remote lab, we work through a remote infrastructure. But behind that, we've got the lab equipment. So you just go through the remote infrastructure, which is a PC or then a server that's been set up so that you're able to not just use the software, but to write programs and then download the program into the PLC and then through video watch to see if your program that you've downloaded, if that works correctly. So there's, for example, the PLC program for traffic lights. So that's one of the activities that the people do when they do the advanced diplomas. So they will program it and then they will load the program into the PLC that you see, and there's the traffic light, and they will then verify that what they've done works 100% correctly. Okay, so yeah, so that's the end of my session. Just the last thing about this picture over here. So you are able to remotely to write your program on you by going into the remote labs. You have access to all the different software that you want to use. So this is just one example, but there's also for power distribution, different programs that you can use to simulate the power distribution system. And then here's the one that you can then simulate, write your PLC program, download it, and see if it works correctly. Okay, so that's the end of my story about the practical aspect, and I'll hand over to whoever's next.
Thank you very much, Vicky. All right, thanks again to all the presenters. So I think you guys have already heard a lot about the program and the institution itself. offering. So I just want to cover the ideal student or the ideal student profile for this program. As you can see, all the highlighted or the bolded words there, we require someone who's motivated, who's curious, committed to learning. I think these are the very really high focus profile attributes that we require in our students, because as you've already heard, there's a lot of learning that needs to take place. I think another thing we can add there is really innovative students, also inquisitive students, because there's a lot of technology that you're going to be working with. So if any of these attributes define you, we are looking for you. So please come join us. And then another thing that we require of the potential students, now that when we look at the admission side of things, we require someone with a strong foundation in mathematics as well as physical sciences, as these are admission requirements. So these really are important factors to take into account. So if you're good in mathematics as well as physical science, the program is for you. And then with regards to support, we support students who may also need additional help with a digital literacy. This is computer literacy. So you'll note one of our admission requirements is someone who's computer literate. But if you don't have any computer training, we do have a test that we've set up as an institution that you are required to take as you apply for the program, and then you need to submit your results with your application. So this is just the type of support that we offer our students as an institution. Um, and then educators can also identify students who would benefit most from our practical career-focused programs. So these are just some of the supports that we offer and just the student profile of our ideal student. All right. And then with regards to the career pathways and industry relevance of our program, I think this is just also a very important slide because as students and having gone through the program as graduates, it is important that you do a program that has got employment opportunities. So this is just some of the things that you guys can go into post graduating with our qualification. So there's just a various list there. I'm not going to read them all out, but these are just some of the career avenues that you can explore. Another important thing there is that on that first sentence, we've got there, graduates will have diverse employment opportunities to pursue careers as registered professional engineering technologist. So that's an important factor to consider because as you would have heard and noted when Lisa explained that we are endorsed by EXA. This is the Engineering Council of South Africa. So with that endorsement comes the opportunity for you to register as a professional engineering technologist, but this can only take place once you've completed all the requirements that EXA requires, which is experience post graduating. So there are just a few tick boxes that you would have to attend to, but then once those are done, you can then register as a professional engineering technologist. So yeah, I think that is it with our presentations. Thank you very much, everyone. And just reminder, if you have any Q&As, please just drop them in the question and answer chat, and then I'm going to attend to them now. But just before I do that, I'm going to hand over again to Lisa, just to mention a few other things. Thank you.
Thanks so much, Busi, and everyone for the presentations. So I just wanted to touch on a few more points before we get to the questions and answers. So we focus on the Bachelor of Engineering Technology and Electrical Engineering because that is what we're rolling out in February 2026. We will be rolling out the Bachelor of Engineering Technology in Mechanical Engineering in July 2026. So if there's anybody interested in mechanical engineering, please take note of that. I think it's also important what Busi mentioned now in terms of the Engineering Council of South Africa. and becoming an engineering technologist. And then I also just wanted to point out that our founder and CEO also founded EIT, the Engineering Institute of Technology, that's been around for many years and is a global engineering institution. So there is a lot of historical knowledge and experience that went into ECST, and that is why we are so industry driven, practically driven, and ensuring that our students be able to absorb into the workplace. So our students also then have an articulation pathway into EIT, or we also have, or there's also ECT, the Engineering College of Technology in the UK, that our students can further their studies with. So just to point those out, and then back to you, Busi, for the question and answer session. Thank you.
Thank you very much, Lisa. So we've got two questions. The first being, are there any plans to add civil or structural engineering qualifications? Qualification. I'll just take this one quickly. So there are plans to add civil engineering that is currently being developed, and we will hopefully be able to offer this within a year or two once that's been accredited and has gone through all the proper channels. So yes, there are plans. And then the second question from Danny, it says, do you foresee, I will try and pronounce this, says mechatronics engineering. So I'm not sure what this is. So I'm going to ask, I'm going to ask Christabel to just please take this one for me. Do you foresee mechatronics engineering?
Oh, yes. Thanks for the question. Indeed, we are planning as well to do this because mechatronics is a course that combines mechanical engineering with electronics. So as you can see, we are offering electrical engineering and we are yet to offer mechanical engineering. So we'll be able to offer a course that combines everything. So there are those students that are just inquisitive and, keen to go for the course of, learning mechanical and at the same time learning electrical engineering. So for sure, yes, in the near future, we will have to do this course. Thank you.
All right. Thank you very much, Christabel. So those are the only questions that we do have. I don't know if anyone wants to just add another question quickly. We still have a few minutes, but I see Lisa's hands up. Lisa?
Yes, thanks, Busi. Dani, just to add to that, the first three qualifications we aim to roll out is electrical, mechanical, and civil, and then we're going to take it further from there. But yeah, Christabel, thank you so much for answering that in detail. And yeah, I just wanted to talk about a few basic questions that we usually get from students and parents. So if you're not from Gauteng, Midrand is very central. It's between Pretoria and Johannesburg. Our campus is in Waterfall Office Park. We're very close to Mall of Africa, but there's a few other centers around us with various amenities. There's public transport. We've got the Gau train close to us. Uber comes into the office park, which is also quite convenient that you don't have to go to the outside of the office park. And we have student accommodation close by, various student accommodation providers that we can recommend. So, and then also sometimes there's questions about loans. So we have a partnership with Student Hero. There is information on our website. So if you wanted to look at that, please have a look at our website and you can get some more information on that. Thanks, Busi.
All right. Thank you very much, Lisa. Thank you very much, everyone, for attending the session, and also just a big thank you to the presenters. So the slide that you're currently looking at, this is our contact details. If you can just please just note them. If you've got any queries, you can just use that query that query email to just send your queries there, or you can access us via our web page, which is also there. We will be sending you, as mentioned earlier, we will be sending you the slides. We'll also be sending you the recording. So you can just look out for this within the next few days. So just thank you again for joining. And we look forward to hearing from you and just getting all the applications. Yeah, thank you very much. Thanks, everyone.
Thank you so much,
Thank
everybody.
you.
Have a
Yes,
lovely
yes, this
evening.
is me.
Thank
Thank
You as well.
you.
you.
Thank
Bye-bye.
you.
Bye.
Okay,
Bye-bye.
goodbye. Thanks.
Bye.